5.25%. That is the number printed on a treasury bond right now. But is it the rate you actually earn? Is it the rate that compensates you for inflation? Is it the rate that prices risk? Oh, the answer is no. It is all of those things combined. And on the CFA exam, you need to know exactly how to take it apart. Interest rates. This is Lesson 1 of CFA Level 1 Quantitative Methods. Every single concept in this course builds on what you learn in the next 10 minutes. Here is exactly what you will master. The 3 ways to interpret an interest rate. The components that build any rate you see. The required rate of return and why it matters. The nominal versus real rate distinction. The Fisher equation. And 5 exam questions with full solutions. Every concept here appears again in fixed income, equity, derivatives, and portfolio management. Let us start with the most fundamental question in all of finance. What is an interest rate? Most students think an interest rate is just the price you pay to borrow money. That is one interpretation, and it is correct. But the CFA exam tests 3 distinct interpretations, and confusing them is one of the most common mistakes on the exam. Think of it this way. If I lend you $100 for 1 year at 5%, that 5% simultaneously represents 3 different things. Interpretation 1. A required rate of return. This is the minimum return an investor demands for giving up their money today. Think of it as the price of waiting. If I could invest my $100 elsewhere and earn 5%, then you must offer me at least 5% to convince me to lend it to you instead. Interpretation 2. A discount rate. This is the rate we use to calculate what a future payment is worth right now. If someone owes me $105 1 year from now and the discount rate is 5%, that promise is worth exactly $100 today. Same number, different perspective. Interpretation 3. An opportunity cost. This is what I give up by choosing one investment over another. If I lend to you at 5%, I cannot simultaneously invest that same money in a treasury bond at 5%. The interest rate measures what I sacrifice. Here is why this matters for the exam. When a question says discount rate, it is asking you to calculate present value. When it says required rate of return, it is asking what rate makes an investment worthwhile. When it says opportunity cost, it is asking about the next best alternative. Same 5%, 3 different questions, 3 different calculation setups. The CFA exam will use all 3 phrasings. Now let us take that 5.25% apart. What is actually inside it? Think of an interest rate like a layer cake. The bottom layer is the real risk-free rate. This is the pure time value of money. No inflation, no risk. Just the reward for waiting. In theory, this is what you would earn in a world with 0 inflation and 0 chance of default. In practice, it is a mathematical concept, not something you can directly observe. Economists estimate it at roughly 1 to 2%. The real risk-free rate is written as R star. It represents the theoretical return with 0 inflation and 0 default risk. Think of it this way. Even in a perfect world where prices never change and no borrower ever defaults, you would still want something for giving up your money today. That something is R star. It compensates you purely for the passage of time. On top of the real risk-free rate, we add an inflation premium. This compensates you for the expected loss of purchasing power over the life of the investment. Here is the intuition. If inflation is 3% this year, then $100 today buys what $103 will buy next year. So the lender demands at least 3% more just to break even in real terms. The key word is expected. The inflation premium is based on what investors think inflation will be, not what it actually turns out to be. If they are wrong, someone wins and someone loses. The nominal risk-free rate equals the real risk-free rate plus the inflation premium. This is the rate you actually observe on a government treasury bill. When the CFA exam says risk-free rate without the word real, it means the nominal rate. This includes inflation. When it says real risk-free rate, it means R star alone before inflation. This distinction is tested constantly. Nominal includes inflation. Real excludes it. Now we add the risk premiums. These compensate investors for taking on risk beyond a government bond. Default risk premium. The chance the borrower cannot pay you back. A corporate bond pays more than a treasury because the corporation might default. The government will not, at least in theory. Liquidity premium. How easily you can sell the investment if you need your money back. A treasury bond is extremely liquid. You can sell it instantly. A small corporate bond might take days. That delay costs you. Maturity premium. How long your money is tied up. A 30-year bond pays more than a 1-year bond because more things can go wrong over 30 years. You want compensation for that extended uncertainty. Here is the complete formula. The required interest rate on any security equals the real risk-free rate, plus the inflation premium, plus the default risk premium, plus the liquidity premium, plus the maturity premium. Notice the first two terms together form the nominal risk-free rate. The last three terms are the risk premiums. This formula is the foundation for how the CFA curriculum thinks about interest rates everywhere. Let me show you what each piece means with a real example. Let us build a real interest rate from the ground up. Step 1. The real risk-free rate is 1.5%. That is just the reward for waiting. Step 2. Add the inflation premium. Investors expect 2% inflation this year. Now we are at 3.5%. This is the nominal risk-free rate, roughly what a T-bill pays. Step 3. This is a corporate bond, so we add the default risk premium. The company has some risk of default, 1%. We are at 4.5. Step 4. This bond is not very liquid, not many buyers and sellers. Add 0.5% liquidity premium, 5%. Step 5. The bond matures in 10 years, so we add a 0.25% maturity premium. Final required rate, 5.25%. That is where the 5.25 came from. Every basis point has a reason. Now the Fisher equation. This is the precise mathematical relationship between nominal rates, real rates, and inflation. 1 plus the nominal rate equals 1 plus the real rate times 1 plus the expected inflation rate. Why is it multiplication and not addition? Because the real return and inflation compound together. If you earn 2% real and inflation is 3%, you do not earn 5% nominal. You earn 1.02 times 1.03, which is 1.0506. The nominal rate is 5.06%, not 5%. The extra 0.06% is the cross product. It is small, but it exists. And the CFA exam tests whether you know the difference between the exact Fisher equation and the linear approximation. Here is the approximation versus the exact answer. The linear approximation says nominal roughly equals real plus inflation. 2 plus 3 equals 5%. The exact Fisher equation says 1.02 times 1.03 equals 1.0506. Nominal is 5.06%. The difference is only 6 basis points here. But with higher rates, the gap widens. At 10% real and 10% inflation, the approximation says 20% nominal. The exact answer is 21%. That is a full percentage point. The exam will specify whether to use the exact or approximate formula. If it does not specify, use the exact. Let me show you what happens when someone in a position of power confuses nominal and real interest rates. In the 1970s, U.S. inflation averaged 7.4% per year. Nominal interest rates on savings accounts were around 5%. Savers thought they were earning money. They saw their balance go up every quarter. But in real terms, they were losing 2.4% per year. Their purchasing power was shrinking. $100 in a savings account in 1970 was worth $62 in real terms by 1980. Savers who understood the difference between nominal and real rates moved their money to inflation-protected assets. Those who did not lost almost 40% of their wealth in a decade. One concept: real consequences. Time to test yourself. Time to test yourself. Pause if you want to work each answer before I reveal it. Question 1. An interest rate is best described as which of the following? A. The rate of return on the safest investment. B. The rate needed to make an investor indifferent between consuming now and saving. C. The cost of borrowing is set by the central bank. The answer is B. If you chose A, that describes only the risk-free rate, not interest rates in general. Interest rates on risky assets are not the safest return. If you chose C, that describes the policy rate, which is only one specific interest rate. Interest rates exist in any economy regardless of central bank actions. B is correct because the fundamental economic meaning of an interest rate is the price that makes savers willing to postpone consumption. If the rate is high enough, you wait. If not, you spend now. Question 2. The nominal risk-free rate is best described as containing which of the following? A. The real risk-free rate and a default risk premium. B. The real risk-free rate and a liquidity premium. C. The real risk-free rate and an expected inflation premium. The answer is C. This is a critical distinction. If you chose A, remember the risk-free rate by definition has no default risk. Treasury bills are considered default-free. There is no default premium in a risk-free rate. If you chose B, same logic. Treasury bills are the most liquid instrument in the market. There is no liquidity premium. C is correct because the only difference between the real and nominal risk-free rate is inflation compensation. The nominal rate is what you see on a T-bill. The real rate is what you earn in purchasing power terms. Question 3. The real risk-free rate is 2% and expected inflation is 3%. Using the exact Fisher equation, the nominal risk-free rate is closest to A. 5%, B. 5.06%, C. 5.1%. The answer is B. 5.06%. Here is the calculation step by step. 1 plus the nominal rate equals 1 plus 0.02 times 1 plus 0.03. That is 1.02 times 1.03 equals 1.0506. Subtract 1. Nominal rate is 0.0506 or 5.06%. If you chose A, 5%, you use the linear approximation 2 plus 3. That is close but not exact. The exam asks for the exact Fisher equation. The trap. Whenever the question says exact or Fisher equation, you must multiply, not add. Choice A is always the wrong answer trap on Fisher equation questions. Question 4. A corporate bond yields 6%. The risk-free rate is 3%. The default risk premium is 1.5% and the liquidity premium is 0.5%. The maturity premium is closest to A. 1%, B. 1.5%, C. 2%. The answer is A. 1%. This is simple algebra using the rate composition formula. Required rate equals risk-free rate plus default risk plus liquidity plus maturity. 6 equals 3 plus 1.5 plus 0.5 plus maturity premium. 6 equals 5 plus maturity premium. Maturity premium equals 1%. If you chose B, 1.5, you may have confused the default risk premium with the maturity premium. If you chose C, you probably subtracted only the risk-free rate from 6 and forgot to subtract the other premiums. Question 5. Which risk premium is most likely to increase when a bond issuer's credit rating is downgraded from A to BBB? A. The maturity premium. B. The liquidity premium. C. The default risk premium. The answer is C. The default risk premium. A credit downgrade directly increases the probability that the issuer cannot pay its obligations. That is default risk by definition. If you chose A, the maturity premium relates to the length of the bond, not the issuer's creditworthiness. A downgrade does not change when the bond matures. If you chose B, there is an indirect argument that downgraded bonds become less liquid. And in practice, yes, the liquidity premium might increase too. But the question asks which premium is most likely to increase. Default risk is the direct and primary effect. Exam tip. When you see a credit rating change, think default risk premium first. Cheat sheet. Pause this now and screenshot it. Every key concept from this lesson on one screen. Exam strategy. How to never lose a point on interest rate questions. Strategy 1. When you see the word nominal, it includes inflation. When you see the word real, it excludes inflation. Write this at the top of your scratch paper before the exam starts. Nominal has the letter N. Think N for I inflation I included. Strategy 2. The risk-free rate contains exactly two components: the real risk-free rate and the inflation premium. Nothing else. No default risk, no liquidity premium, no maturity premium. If a question adds any other premium to the risk-free rate, the answer is wrong. Remember, T-bills are default-free, perfectly liquid, and short-term. Strategy 3. When a question says Fisher equation or exact, you must use multiplication. 1 plus real times 1 plus inflation. When it says approximate or uses the word roughly, simple addition is acceptable. If it does not specify, default to the exact method. The wrong answer choices on Fisher questions almost always include the additive approximation. 5 key takeaways from this lesson. 1. Interest rates have three interpretations: required return, discount rate, and opportunity cost. Exam questions use all three phrasings. 2. Every rate is built from components: real risk-free rate, inflation premium, default risk, liquidity, and maturity premiums. 3. The nominal risk-free rate is just the real rate plus inflation, no other premiums. 4. The Fisher equation relates nominal and real rates through multiplication, not addition. The additive version is an approximation. 5. Understanding these components is the foundation for everything else in the CFA curriculum: bond pricing, equity valuation, derivatives, and portfolio theory. Next lesson, we take these rates and put them to work. Time value of money. That is where a single interest rate becomes the most powerful tool in finance. If this video saved you study time, subscribe. Every lesson builds on the last.